Good morning, guys. So we are on topic 9, SAS 2 in our workbook, and we're on pages 229, and we will end at 234. Okay? So we are still talking about rational expressions, and yesterday, you were supposed to complete the notes for topic 9. So if you have not done that, you really need to do that because I give you all the steps for all types of examples. And you really need to have those in order to do today's lesson because today's lesson is just a lot of practice. So if you have not done that, I want you to stop this video and I want you to go to yesterday's video and I want you to write down those notes and keep those by your side while you work through today's lesson. Okay? So, yesterday we defined a rational expression as it is simplified when its numerator and denominator have no common factors other than 1. So if you remember from yesterday, we had to factor out the top and the bottom. The first step every time was that. The last step every time was to cross out those common factors. So whatever you had on the top, if you also had it on the bottom, we crossed it out. Okay? But now Agile Mind does it a little different. They explain, and this is number 1 on your workbook page. It says, what is a rational expression? Well, they define a rational expression as the quotient of two polynomial expressions expressed as a ratio. So what that means, a quotient. What does the word quotient mean? Quotient's the answer when you divide. You know, it's when you have a numerator and you have a denominator and it's expressed as a ratio, which we all know ratio is a fancy word for a fraction. Okay, so that's just another way to explain what a rational expression was. Now it says rational expressions can be used to represent real life situations, as you will see in this animation. So I'm going to play this animation. It says, a carpet manufacturer is trying to control his cost. He knows that his weekly cost to manufacture X rolls of carpet, when X is less than 100, is given by the quadratic expression of negative 3x squared plus 1400x. Okay, so we're given that function. So I'm going to hit play. Okay, so the cost to manufacture just a single roll. So we divide everything by X. If we hit step 2, it tells us that is a rational expression. That is because it is a quotient of two polynomials. So this is a polynomial up top. And this is also a polynomial. So it's the quotient because it is dividing and it is expressed as a ratio. If we hit the third one, it's going to show you that right there is the division. So we're dividing. So remember that long division that we did a couple weeks ago? That's what it's doing right now. So they divided, they multiplied, and now what do you think they're going to do? They're going to subtract, which is what we did last week. So you're left with 0, and then guess what they're going to do? They're going to bring down that 1400x, and they're going to say x goes into 1400x, 1400 times. They're going to multiply, and they are going to be left with what? Nothing. That's right. They're going to be left with nothing. So they have a remainder of 0. Now it says at the bottom, this division won't always be easy. fortunately, there is another way to simplify the rational expression. So here's what they're doing. They factored out that x, they canceled those x's, and you're left with exactly what you got. So out of those two options, this one being where they just factored out an x, they factored out this x right here, and they had an x on the bottom, so they crossed those out, and you're just left with this. Or you could do long division. You could do all this work where you get the exact same answer. So you decide for yourself which one you think is easier. All right, let's see. If we hit the green arrow, we go to page 2. And this is our is an example of what we did yesterday. So we are just simplifying this rational expression by factoring. Okay, so remember yesterday we used what method a lot? We used the big X method, okay? So we're going to continue to use that because it works. It's just easy. It works for everything so far. All right, so for the top, oops. Remember, B goes in the bottom. Well, B is 5. And A times C goes up top. So 1 times 6 is 6. So we want to add to get 5, but at the same time, multiply to get 6. So our only two factors could be 2 and 3. Okay? Now, if we factor, we've done the top, so if we factor the bottom, we're missing what term? We're missing that B term, so we just have to put in a 0. Up top, we have a -4. So we know that one of them is going to have to be negative. So we have a 2 and a -2. Okay, so out of our options for the top, our factors were +2 and +3. And for our denominator, our factors were +2 and -2. Right? Now, the next thing we have to do is cross out the common factor. So what is common? X plus 2 and X plus 2. So you are left with X plus 3 and X minus 2 as my answer for the simplified rational expression. Okay? All right, next on the next slide, page 3, we're also on number 3. So it says, now look at a slightly different problem. What do you notice about the numerator? What kind of function is it? It's a cubic function. So here's where those sum of cubes and difference of cubes formulas come in handy. So we will start on the first one on the top. We have 8x cubed plus 1. Well, we know to get rid of a cube, we must take the cube root. So the cube root of 8x cubed is a 2x. And the cube root of 1 is a 1. Now, why did I use an addition sign? Because what did I start with? I started with this addition sign, so I'm using the sum of cubes. So we have 2x plus 1. And then we have a squared, so that would be 4x squared. And remember, with the sum of cubes, the signs are plus, minus, plus. So we have a 4x cubed plus a 2x plus 1. Sorry, wrong. Hold on. 4x cubed, not 4x cubed, 4x squared minus a 2x plus a 1. Sorry, I'll get it right in a minute. So that's the first one. Okay, now, before we start, on the bottom, on the denominator, in the past, when we do the big X, our A value is always what? It's always been 1. Okay? So when you have something other than 1, you have to do one more step. And here's how it works. You still have your big X. Your B still goes in the bottom. And your A times C goes up top. But this time we're saying 2 times 3 to get 6. Okay? We are still adding to get 7. And we are still multiplying to get 6. So that would be 6 and 1. Now, originally, we would have stopped here. Okay? But since this A value equals 2, we must divide the factors by 2. So I'm saying 6 divided by 2 and 1 divided by 2. Now, if you can simplify those, you want to go ahead and do that. So 6 divided by 2 is what? Well, it's 3. So there's a factor, x plus 3. Now, something like 1/2, I can't simplify it anymore. Here's what you do. Think back to this 3 I just talked about. 3 is a whole number, but if I wanted to make it into a fraction, I would say 3 over 1, right? Now, I would write that factor as x plus 3. What number goes in front of that x that we don't write? That 1. Where do you think that 1 came from? It came from the denominator. So since our denominator here is 2, this factor will be 2x plus 1. Does that kind of make sense? So, we have a factor of, for the numerator, it was 2x plus 1. 4x squared minus 2x plus 1, because remember, the signs are plus, minus, plus. On the bottom, we had a factor of x plus 3, but we also had a factor of 2x plus 1. Now, do you see something in common?
Dude, move around.
I'm videoing.
Right now?
Right now.
Where's your record sign?
I don't have it up. Sorry. The cello busted in my room again. Okay, so since we can mark those out, we just carry what's left. So our answers would be 4x squared minus 2x plus 1 over x plus 3. Okay? All right, another problem that we are doing is we are factoring out the top and the bottom. So look at the top. It's also a cubic. So is it going to be a sum or the difference? I'm thinking a sum because it's addition. So first, we have x cubed plus 64 So we take the cube root of both, and we're left with x plus 4. All right, then we have a squared, which would be x squared. Remember, it's plus minus, and then it would be 4x plus minus plus 16. Okay? So that will be our top. Now, on the bottom, let's split them up. Let's see. All right, so I'm going to erase this so we have some room. All right, so we have 2xw plus 8w plus 3x plus 12. Okay, so we know in order to get 12, when we multiply, we must have a 3 somewhere and we must have a 4 somewhere. Because 3 times 4 is 12. Now, let's see. Let's go ahead and bring down a 2 here. If I want a 2xw, okay? What also has a w? 8, okay? So let's just try 2w plus 3. And maybe x plus 4. This is kind of just like a puzzle. So if I multiply, it's over here, and I had 2w and 3 and x and 4, well, this would give me a 2xw. This would give me a 3x. This would give me an 8w, and this would give me a 12. Is that what I need? Yes. Okay, so now let's go back and let's fill in our blanks. So up top we had an x plus 4. We had an x squared minus 4x plus 16. And look, here's a trick. Here's a trick. You know that there is no way that this second factor can work with the denominator. But you know that if you have an x4 on the top, you're going to go ahead and have to have an x plus 4 on the bottom so you can do what with them? So you can cancel them. That's right. So let's go ahead and put our x plus 4 on the bottom. And everything's positive, so 2w plus 3. Now we cross out what is common, which is the x plus 4s. And then we have this over this. Okay, that one's a little bit different because you have the 2xw and the 8w and the 3x. So that one's kind of like a puzzle. You have to kind of mess around with it. All right. Let's see. So here is, remember long division and synthetic division? So this picture up top is showing you the steps, which we know how to do this because we've done it before. So I'm going to go here and we're going to do, so we are going to do synthetic. Our problem is x cubed plus x squared minus 10x plus 12 over x plus 2. So remember, when you do synthetic, you must find the 0. This is the factor. We must find the 0 of that factor. So we say x plus 2 equals 0. We subtract 2 and we're left with x equals negative 2. So when we draw our upside down L, this goes on the side. And remember, on the top are your coefficients. So for x cubed, it's 1. For x squared, it's 1. For x, it's negative 10, and the constant is 12. So remember, the first step is you always bring down the first term. And then we multiply. 1 times negative 2 is negative 2. Then we combine. 1 minus 2 is negative 1. We do the same thing. Negative 1 times negative 2 is a positive 2. So that we combine those. Negative 10 plus 2 is negative 8. We multiply and we get a positive 16. We combine and we get 28. Now, remember from a few weeks ago when we did synthetic and long, your answer, your quotient, always starts with 1 less power. So, since we started with an x cubed, we're going to start with an x squared. So, we're going to have an x squared, we're going to have an x, and we're going to have a constant. So, we have 1, negative 1, negative 8 is my constant. So now, plus 28 over x plus 2 is my remainder. Now, it says, verify this. Excuse me. Verify this using long division. All right, so we have x plus 2 here. And then we have x cubed plus x squared minus 10x plus 12. So we start by saying x cubed divided by x is x squared. Then we multiply. X squared times x plus 2, and we get x cubed plus 2x squared. When we subtract those, these cancel, and I have 1 minus 2, which is a negative 1x squared. So then I start my process over. Negative 1x squared divided by x is negative 1x. So I can just say negative x. Negative x times x plus 2 is negative x squared minus 2x. Well, oops, we forgot to bring down this. When I subtract, these cancel, and I'm left with negative 8x. I bring down that positive 12, and I say negative 8x divided by x is a negative 8. And then I multiply, and I get negative 8x minus 16. When I subtract, this goes away, but these two negatives make a positive. So I have 12 plus 16, and that's 28. So that is my remainder. So it works both ways. Let's see. All right, if you go to, let's see, number 6, it says to add the following rational expressions. So let's see what this, this is the problem. No, this is not the problem. Okay, so this is just showing you that your denominators have to be the same in order for you to add or subtract rational expressions. It's just like adding and subtracting a fraction. You cannot add or subtract a fraction if your denominators are the same. So that's all this part is showing you. If you click the next arrow, let's see what it does. Okay. This example, there's 2 over 5 and 3 over 10. You see that the 5 and the 10 are not the same. But what did I just say? They have to have a common denominator. So what Agile Mind did, they broke up 10 and said that 5 times 2 was 10. Everybody agrees, right? So now my left denominator only has a 5, but the right has a 5 and a 2. So in order for those to be the same, you must multiply by the missing term on the top and the bottom of the opposite side. So let me rephrase that so it's a little bit easier. Here's a 5, here's a 5 and a 2. What is this left side missing that the right side has? Well, it's missing the 2. So we take that 2 and we multiply on the numerator and the denominator of the missing side, which is what they did right here. They multiplied by 2 on the top and the bottom. Now, they got 10 because they simplified. They said 5 times 2 is 10. Okay? They got 4 because 2 times 2 is 4. Now, once your denominators are the same, you can simplify. You only simplify the numerator. You do not say 10 plus 10 is 20. You leave your 10 and you simplify the numerator. In yesterday's notes, it was the last section that we did, adding and subtracting. We wrote the steps down. Go back and look at them. I promise it tells you exactly what to do. Okay? So now, if we hit number 3, it's going to show us the problem that we're doing on number 6. Okay, let me pause right there. Whoops. Okay. So, yesterday I talked it through, so I'm going to talk it through today. So, you cannot simplify this 2. You cannot simplify x plus 2. And you cannot simplify 2. So if you look, they brought all of those terms over and then they brought them down. However, you can simplify this. They just did it in their head without any work. Some of you can do that. However, some of you cannot. So we have our x. We're missing that b. And here's the a times c. A in this case is 1. So this has to be 2 and negative 2, which is where this and this came from. Okay? Now, I'm going to hit play again. Oops. Just a minute. Okay? Now, it's showing you that the right side has an x plus 2 and an x minus 2. On the left side, it originally only had x plus 2. So what they're doing is they are taking that missing term and they're multiplying on the top and the bottom of where it's missing. All right, they simplified. They say 2x minus 4. All they did was distribute that 2. Now, before I hit the number 4, are my denominators the same now? Yes. So the only thing left to do is combine the numerator. They brought the denominator down because it's common. They brought the numerator down. They have a 2x minus 4 plus 2. They're going to combine that negative 4 and 2, and they're going to be left with 2x minus 2. So, if you want to pause the video here and write these steps down for number 6, please go ahead and do that. All right, on number 7. So, they have went ahead and brought the 2 and the negative 5x over for you because you can't simplify that. But there's another thing. What can't you simplify? Well, you cannot simplify x plus 3 either. Okay? So, our job at this moment is to simplify x squared plus 7x plus 12. 7 in the bottom, 12 up top. Has to be 3 and 4. Okay? So our two factors here are x plus 3 and x plus 4. Now, are our denominators the same? Nope. Do they need to be the same? Yep. So, the right side has everything we need. However, the left side only has an x plus 3. What's it missing? It's missing the x plus 4. So, we must multiply by x plus 4 on the top and the bottom of the side that's missing it. Okay? Now, since my denominators are the same, I can bring them straight down. And all that's left to do is combine the top. So, I have a 2 times x plus 4 minus a 5x. So we have 2x plus 8 minus 5x. Well, when we say 2 minus 5, we get a negative 3x plus 8. Okay? Okay, so I am only going to do 8A for you, and I would like for you to do 8B and C. And then later this afternoon, I will upload a document onto Teams of the answers for 8B and C with the work, but I want you to try it on your own. But I am going to work through the first one with you. So the problem is 5 over x squared plus 3 plus 7 over 2x squared plus 1. Okay. Before we start, can you simplify the number 5? Nope. Can you simplify x squared plus 3? I don't think so, but we can try. So we have a 0 in the bottom and a 3 up top. The only thing that's 3 is 1 and 3, and that don't give us 0, so that don't work. So we cannot simplify x squared plus 3. We cannot simplify 7. Can we simplify 2x squared plus 1? Maybe, but probably not. So we're missing this term. And a times c would be 2. So the only thing that multiplies to 2 is 1 and 2, and that doesn't get 0, so that doesn't work. So we cannot simplify any of them. So what do? Are our denominators the same? Not at all. 2 completely different things. But what you can do, the left side is missing the right side, and the right side is missing the left side. So here's what I'm going to do. Now, is the top the same? The top's not the same, but is the bottom the same? Yeah. Does it matter the order of what we write those factors in? No, because it's multiplication. So now, what I did, I took what was missing on the left and I multiplied it on the top and bottom on the right. And I took what was missing on the right and multiplied it on the top and bottom of the left. So I just multiplied each side by each other's factor. So now all you have left to do is simplify the top. So let's see. 5 times 2x squared plus 1 plus 7x squared plus 3. So that is 10x squared plus 5 plus 7x squared plus 21, which leaves us with 17x squared plus 26, and all over our denominator that we made common, which was x squared plus 3 over 2x squared plus 1. So here is my answer. Okay, so on B and C, you notice that the denominators are also not the same. And just a hint, you cannot simplify any of the numerators or denominators. So on B and C, you are going to have to do what I just did. You're going to have to multiply by that missing denominator for both sides, okay? So try B and C on your own, and it's just a check, so it actually has the answers, and I think it probably even has the work for you. So just check, or after you get done, check those, and I will, I won't need to upload the answers because it has the work for you. So work B and C on your own, and check them when you get done. All right, next is number 9. And number 9 can be very simple. Okay, so we're working on this left problem first. Okay. Oh, they're going to keep going. Hold up, I need them to stop. Okay. Ow. Poke myself in the eye. All right. I think I'm going to go and do this on my own. All right, so we have 4 over 5 times 25 over 28. Now, what I'm trying to get is something that I can cross out. Okay? So if I have a 5 on the bottom, from 4 over 5, I want a 5 on the top. So I'm going to simplify 25 to be 5 times 5, right? Now, if I simplify 28, I want to have it with the 4 so I can cross them out. So it would be 4 and 7. So here's where we would squish them. 4 times 5 times 5 over 5 times 4 times 7. And you just mark out the common factors, or the common numbers. So we're marking out a 4, a 4, a 5, and a 5, and I'm just left with 5 over 7. Okay? And that's what I John mine was doing too. They squished them, and they're going to cross out the 4s. They're going to cross out the 5s, and you're left with 5 over 7. For the next one, I almost think we've done this problem. So they factored in x. They are squishing. And guess what they're going to do next? They're going to cross out. So they're crossing out x minus 2s. They're crossing out x plus 2s. And they are crossing out x's. So that just means it is left with the number 1. All right, this is not on here. But I do want to talk about division. So let's watch it. So remember, division, you must first, what they're going to do is they're going to separate that. Oh, they went ahead and did that. Okay, let's back up. Okay. In yesterday's notes, go to the division part. And I said, if you went to Alamo and you had Miss Mary Kate Gorley for 6th grade math, then you learned keep, change, flip. This works for division problems. You keep the first. Here and here. You change the sign. And you flip the fraction, the second fraction. So you keep, you change, and you flip. Okay? Now, let's see what number 5 does. All right, so they're going to split that into 3s. They're going to split that into 2s. And then they're going to squish them, I bet. Oh, they're over here on this side. Factoring. 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 And factoring. All right, so I'm going to... Okay, it's going to pause. Okay, so the problem on the left side, they split the 9 and got 3 times 3. Right here. And they split the 4 and got 2 times 2. So what they're going to do next, they're going to squish them and then they're going to cross out and they'll be done. Now, over on the right side, they had to do a little bit more work. However, they didn't show their work. I'm going to show it for you. They used the big X, or they just factored all of them. So they had a 0 and a negative 25, and they got a 5 and a negative 5 for the top. The other top would have been 2 and negative 8, and that would have been 4 and a negative 2. For the bottom, everything's positive. 8 and 16, so you know it has to be two positive 4s. And the other denominator was a negative 10 and a 25, so you know it has to be two negatives. Okay, so that's how they got those. Now, what they're going to do next is let's see, number 6. Look, they're going to squish, I bet. Yep, squish. And then they're going to cross. And they're going to cross. And they're going to be left with 3 over 2. For number 7, I bet they squish. And then they will cross. And they will cross. And then they will be left with that answer because there's nothing else in common. Oh, they factored it back out. So you can factor it or multiply it back out, or you can leave it like it is. Either one is fine. So, I actually want you to do, let's see, does number 10... Okay. Number 10, you have a word bank. So, let's see. Okay, I do want you to do All right, I do want you to try number 10 on your own. I will go ahead and make a separate video right after I upload this one of me working out number 10. But go ahead and try number 10. So it's 2 multiplication problems and 2 division. Just remember, for division, keep, change, and flip. And then once you keep, change, and flip, it's back to multiplication. So you can do it on your own. Okay? Try those. I'm going to go ahead and upload this, make another video for number 10. And go ahead and try number 11 while you're at it. And I'll make those, and I'll go ahead and get that uploaded after lunch so you have time to work on it. Let me know if you have questions.